Welcome to qnawire.
So now we're going to work on problem 32 from chapter 13. In this problem, we're asked about several pairs of ions, specifically which of the pairs in each pair has the greater charge density. So our first pair is sodium plus or cesium plus. Now the two factors affecting charge density are charge and size. So in order to have a high charge density, we need a high charge and a small size. So if these things go up and down respectively, we're going to have a greater charge density. So between sodium and cesium, we have the same charge. The charge is the same, but the size of sodium is much smaller because it's much higher on the periodic table. And so sodium would be the answer here because it's smaller. In our second pair, we have strontium 2 plus or rubidium plus. So strontium has two charges, so it does have higher charge, and it does also have a smaller ion radius. So for both reasons, strontium 2 plus is the higher charge density, and it has more charge. In part C, we're looking at sodium plus or chlorine plus. So they both have the same charge magnitude of charge. Even though one is positive, one is negative, we have the same magnitude. However, so the issue comes down to size, sodium or chlorine. Now, this is where it's important to remember the periodic trends. It might be easy to think sodium would be smaller because it has the lower atomic number, but it's actually chlorine because if you remember, size decreases as you go across the period because of the larger number of protons able to hold the electrons closer to the nucleus. So chlorine is smaller. And D, we have O2 minus or F minus. So here, oxygen has more charge. Fluorine would be slightly smaller, but the bigger factor here is the additional charged unit. So O2 minus has more charge, so it's higher charge density. So let's go back to black for E. In part E, we're given hydroxide or SH minus, the sulfur analogous of hydroxide. Sulfur analog. So we have the same charge for both of them. Both of them are one negative charge. But oxygen is much smaller than sulfur because it's higher up on the periodic table. So it has the higher charge density. Even though this is a polyatomic ion, the rules don't change. The hydrogen is the same for both of them, so you just compare the oxygen and sulfur atoms to see which is bigger or smaller. In part F, we have magnesium 2 plus and barium 2 plus. So they both have the same magnitude of charge, so we want to select the smaller one, which would be magnesium, because it's higher up on the periodic table. Then we move to G, where we have magnesium and sodium. So magnesium is has more charge, it has twice the charge, and it is actually smaller because it just slightly, but it's further to the right, so it's smaller. So for it's two reasons it has the higher charge density. And finally, in part H, we have nitrate, NO3 minus, or carbonate, CO3 2 minus. Here, charge is really negligibly different. We have 3 oxygen, and we have carbon and nitrogen, which are right next to each other on the periodic table, so not a huge difference there. So the issue comes down to the fact that we have 2 charges on the carbonate. So because it's smaller, it has the higher charge density.